What happens if you are trying to do an independent samples t-test and you fail normality, for example? Or what if you've got a different kind of data? You can't use an independent samples t-test because you don't have continuous data. What do you do? Well, instead you could run what's called the Mann-Whitney U-test. A Mann-Whitney U-test, which is also called a Wilcoxon rank sum test, because everything's got a lot of different names and stats, is used to determine whether two groups' medians on the same continuous variable differs. So it's similar to an independent samples t-test, but instead of using means, it's using medians. It's a non-parametric test, which means you do not need to meet the assumption of normality. And I've left you some help guides for if you're trying to run a Mann-Whitney U-test. Reminder, it's called a Wilcoxon rank sum test as well, so sometimes people will call it the Wilcoxon test. Every test we run has certain assumptions that must be met in order for the results of the test to be valid. The first assumption for the Wilcoxon test is the dependent variable must be ordinal or continuous. So if you've tried to run an independent sample t-test and you failed normality, this might be why you would run this Mann-Whitney U-test. Or maybe you wanted to run an independent samples t-test, but you had the wrong kind of data. You have ordinal data instead. And in that case, you can't use the independent samples t-test. You could instead run the Mann-Whitney U-test. So to run the Mann-Whitney U-test, we must have either continuous data, so int or double or numeric data types, or we have to have ordinal data, which is the ordered factor data type. If you were just here for independent sample t-test, you've already done lines 145 and 146. So we can run right to 147, which is taking a glimpse of our data. We can look at our data and say, what kind of data do we have? Fake data 1 is listed as DBL, or double, which is RStudio's way of saying continuous. So we've passed this assumption because the column we're trying to use is continuous data. What if you were trying to use a different column and a different data type? I've left you some code for if you were trying to use, let's say, the group column. The group column has the values 1, 2, 3, and we might want to set that to ordinal data. Maybe 1 means small group or small drink, 2 means medium drink, and 3 means large drink. There's a certain order there. It has to go 1, 2, 3 or 3, 2, 1. You can't say 2, 1, 3, i.e. it's ordered data. There's a certain order built into this data. If you were trying to use something that's ordinal in this test, I've left you some code for how to change it to the correct data type. So here we've got on line 151, fake underscore data $group is equal to factor, left bracket, fake underscore data $group, comma, order equals true in all capitals, comma, level equals C, which is the concatenate function, left bracket, in quotation marks 1, comma, in quotation marks 2, comma, in quotation marks 3, end bracket, and second bracket. If I run this, we get some blue text in the console, and I can ask a function we actually haven't used yet. It's called the class function. We can ask just for fake data $group, and it says the class of this column of data is an ordered factor, i.e. we set it to ordinal data. So if you were working on your own research data and you're like, Lindsay, I'm not working with continuous data, how do I do this for ordinal? That's what we just did on line 151 and 153. We set this to ordered factor. We're not using that today. We're still going to use fake data 1, which is continuous. So this is if you're trying to work on your own data and you're like, how do I set it to the other data type, please? So we've passed assumption 1. Fake data 1 is continuous data. Assumption 2, our independent variable must be categorical with 2 independent groups. It means you can only be in group 1 or group 2. You can't be in both. If you were just here for independent sample t-test, we already did this, but let's review really quickly. I've left you some code for just in case in your fake data set, something like gender has imported incorrectly. If it's given you some weird symbols and it's not working right, I've given you some code to fix that. It sometimes happens if you're working on an older version of RStudio. But what we're trying to do right now is make sure our gender column is set to the correct data type. If you've just opened the data set, it actually won't be set to factor yet. It will be set to it. So to change that, you run line 169, which is fake underscore data $ gender is equal to as dot factor left bracket fake underscore data $ gender end bracket. We've actually already done this, but I can run it again. And when I take a glimpse of my data, gender is set to factor. So we meet that check mark. We've got 2 independent groups. We've actually got men and women. You were just here for independent sample t-test. How do you do that? You can change the zeros and ones by running line 174. If I try to run this right now, I think it's actually going to break because right now we don't have any zeros and ones. So let me run this. Oops, we already did this. We already have 0 equals men and 1 equals women. So if I try to run the line again, it says error in recode, unused arguments, i.e. it can't find any zeros and it can't find any ones, so it's not working properly. So if you're just logging in just for this test, you'll have to make sure if you want the words that you do something like 174 to recode the zeros and the ones. Okay, so we've passed assumption 2. Our independent variable is categorical. It's set to FCT or factor data type. And we've got 2 independent groups. You're either in the men group or the women group. You're not in both. Assumption 3, our data must be independent. Independence is a little hard to check after the fact, and if you were just here for the independent sample t-test, hi, hello, you've already done this with me. If we look at our data set, we want to make sure that each row is a unique participant. You don't want someone having 2 or 3 rows. It's considered cheating, but each row is a unique participant, and hopefully there's no relationship between the different people. So hopefully they're not all my best friends. Hopefully we've done some kind of random sampling. So we've got different people who don't necessarily know each other and aren't necessarily going to have similar answers. So at the fake data set today, we'll say we've met the assumption of independence. And then this one is new. If you're here just for the Mann Whitney U test, we haven't seen this one before. This is assumption 4. Both groups' distributions should have the same shape, which means if we've got our large data set with the men and the women, we can filter the data set so we've got a smaller version for men and a smaller version for women. We just did this in the independent sample t-test. And we plot them. We want to plot them in a histogram and visually look at the 2 histograms and say, do they look approximately the same? Do they have a similar shape? So we can actually run this on line 186. We're going to do the hist function to do a histogram of men $fake data 1. And on line 187, we can do the same thing, histogram of the women, the filtered data set for fake data 1. So I can run both of these at the same time. And down in the bottom right, we'll get 2 different graphs. So here we have the women graph. You'll see it's just like an approximation where you've got between the values of 85 and 90, and we've got most of the folks are between 86 and 87. So we've got a chunk of the data on the left, and it's a little bit lower on the right. What do the men look like? I can click this blue arrow to go back to the other graph because they ran them at the same time. Ooh, that doesn't look super duper the same. We've still got like 85 to 89 on our x-axis down here for the men, but the left side is pretty low and the right side is pretty high. So if I flip it back and forth between these, those don't really look like the same shape. They're actually kind of opposites. So what this would indicate is if this was your actual data set, you have probably failed assumption 4 because the distributions don't look like the same shape. Today, we're going to say it's totally fine because it's just a fake data set. We're just doing it for practice. But if this was your actual data set, you might not have met this assumption because the shapes don't look super similar. Okay, so it's just a warning. Always check your assumptions because you don't know if you've met them until you actually check them. And I've left you an expert tip. Non-parametric tests do not care about outliers. So if you remove the outliers for the independent sample t-test, but then you realize you can't actually use that test, and now you're coming to the Mann Whitney U test, you can actually put those outliers back in because they're 2 different tests doing different things. So this is not an assumption of this test. We don't have to remove outliers. You can leave them in if you're doing the non-parametric test. We've checked our assumptions. How do we actually run the Mann Whitney U test? You might need to run line 199. It's install.packages, left bracket, quotation mark, rstatics, RStatix, end quotation mark, end bracket. I already have this on my computer. I don't need to run this, but I do need to run line 200. This is the first time I'm using this package today, so I'm going to run line 200. I get some red text. It says attaching package RStatics. The following objects are masked from package effect size, Cohen's d and eta squared. And the following object is masked from package stat filter. This isn't an error code in the sense that it didn't work. This is just a warning saying you've got different packages that have the same functions and they're kind of fighting. They're trying to say which one is going to win right now. So that's okay. It's just more of a warning. If you got an error code saying you need to install the coin package in order to use the RStatics package, which might happen if you've done this for the first time, you'll need to run what's on line 202. You have to install the coin package before you can do anything else. If you didn't get that error code, you can ignore line 202. You probably already have this and it's already working fine. Okay, how do we actually run the Wilcox_test function? We can run line 204 to get a little bit of help. It's $Wilcox_test, left bracket, right bracket. And if we run this in the bottom right in our help window, we get Wilcox_test, squiggly brackets, RStatics. It's from the RStatics package, which we just installed and loaded. It says Wilcoxon tests, description, provides a pipe-friendly framework to perform 1 and 2 sample Wilcoxon test. Read more Wilcoxon in R. So you could open this for additional documentation. Usage, Wilcox_test. It's got a bunch of different pieces that you could give it. What do we actually need here? We need to give this function our dependent variable, which is fake data 1, tilde, and our independent variable, which is gender. And we need to say paired equals false. This is an independent samples t-test. We don't have 2 paired observations. It's independent, so paired is false. We're going to see paired equals true if you're coming to the paired sample t-test version, which is going to be in January. So let's actually run this. What does it look like? On line 206, Wilcox_test, left bracket, fake_data 1, tilde gender, comma, data equals fake data, comma, paired equals false. This setup will run the independent sample t-test comparing gender on fake data 1, which is to say, is the fake data 1 median different for men versus women? We can highlight this and click run. And what do we get? It gives you in blue text the thing you ran, and it says it's returning a tibble, which is a data type. Don't worry about it too much. We've got fake data 1. We're comparing the men to the women. There are 15 observations, or the N is 15 for men, and the N is 15 for women. We've got equal groups. Our statistic gives us the value 153, and we've got a p-value is equal to 0.0975. If p is less than 0.05, we can say the median is different between the 2 groups. One of them is higher than the other, or we can say it the other way around. One is lower than the other. Here, our p-value is greater than 0.05. So we can say we fail to be able to say whether the medians are different between the groups. I didn't say they're not different. I said I fail to be able to say whether they are different. The p-value does not tell you how big this effect is. It just says, can we say they are different? Can we say there's statistical significance? So we might want to do an effect size to determine how large is this actual difference. The effect size for the Mann-Whitney U-test, which is also the Wilcoxon rank sum test, is R, which is not the same as Pearson's R, just to make things confusing. So to get R, we can run Wilcox_effect size, or F size, EFF size, left bracket, fake data 1, or tilde, gender, comma, data equals fake data, comma, paired equals false. So it's the exact same text as you just gave the Wilcoxon test, but instead of Wilcox_test, we're going to use Wilcox_F size. So we can click on line 209, we can run it. And it gives you some output. So it says fake data 1. Group 1 is men, group 2 is women. Our effect size is 0.307. And we've got a sample size of 15 for men and 15 for women. How big is the effect size? It actually gives you some words. It says this is a moderate effect size or a medium effect size. Anything from about 0.2 to 0.4 is generally considered medium, if I remember right, somewhere in there. How would you actually write this if you're doing this for a paper? You would say U, which is the Mann-Whitney U statistic. So if I'm looking here, our U statistic is right here. U is equal to 153, and P is equal to 0.0975, and R, our effect size, is 307. You might also want to give the medians of the two groups because this test uses medians. So you can use the median function to say, of the men, what's the value of fake data 1? And on the next line, we can say, use the median function of the women, what's the median of fake data 1? We can run this. The men, the median is 87.6. And for women, the median is 86.7. Those are not different enough for us to be able to say they're statistically different. Even though there's a little difference, it's not enough to say they're statistically different. So that's how you'd write the results of the Mann-Whitney U test. And then the last thing you might want to do is you might want to graph. The best graph for a Mann-Whitney U test is actually a box plot. So we're not going to go into too much detail about this, but I've left you the code for a box plot, just a very basic one, on line 219. So we can highlight this and click Run. And in the bottom right in our plots window, I can click Zoom to look at our box plot. We've got gender on the x-axis. On the left, we have the men. On the right, we have the women. And on our y-axis, all the way on the left, it says fake data 1 median, because this is medians, not means. If you're not familiar with box plots, the thick black line in the middle is the median. So you'll notice on our y-axis, this goes from 85 to 89. So it looks like these groups could potentially be different because it looks like these are really far away. But if you notice, there's a lot of overlap between what we call our whiskers. And the boxes actually overlap quite a lot. If I was to change this y-axis to go from 0 to 100, the boxes would be very close together right at the top, pretty much touching. So it's not different enough for us to be able to say they are statistically significantly different. Our p-value is greater than 0.05, and that kind of makes sense because we've got overlap between our boxes, we've got overlap between our whiskers. The big black line is your median. We've got our interquartile range. We've got our whiskers. And if you have any circles outside, so we've got one circle down here for men and one circle up here for women, if you were doing visual inspection, we might be able to say those are outliers. We don't care about outliers for the Mann-Whitney U test, but if we did a we did a box plot for visual inspection for the independent sample t-test, you might say that these are outliers for that test and remove them for the independent samples t-test. So we've covered how to run the Mann-Whitney U test. We did all the assumptions, we ran the test, we interpreted it, and we made a graph. And that's how you do a Mann-Whitney U.